Welcome to vblog 53. This is Business 135, fun with Excel and math. Hey, we're having fun in this chapter because we're doing things like planning for retirement, seeing how to become a millionaire. Hey, we're about to move on to present value. However, we got to go back. Let's go back to FV3, and hopefully some of you caught this. But I want you to look right here. We did a calculation future value, and then we used it in a subsequent calculation here, and we didn't round it. So let's come back over here, and we're going to, in cell B19, we're going to click right up in the formula bar. Now, if you're going to edit existing formula, sometimes it's easier to go, after clicking in the cell, go up to the formula bar and type your amendments to the formula there. So I'm going to type round, open parentheses. Then I just got that whole thing there, and that's the number. So I go to the end, comma 2, close parentheses. 1,200,000. Not only that, but looks like FV1B19. So we're going to go over to FV1 here, and B19. Oh, we didn't round that one either. So we're going to come over here. ROUND, open parentheses. Click at the end, comma 2. Again, the idea here is we're multiplying and dividing decimals all over the place. And if we, for dollar amounts, these up here when we divide interest rate, we don't want to round those. But here we got a dollar amount that needs to be rounded to the penny. So we're going to put our round. All right, let's go back to FV3, and there we go. We have rounded both the one in B19 right there, and also the one over in FV1 B19. So now we have no problem with that one. Oh, wait a second. Do we need to round this? No way. We're subtracting here, adding or subtracting. If you already have rounded numbers, you don't need to round. Let's go to FV4. We did the same thing here. B19. Let's come up after clicking in that cell to the formula bar, and we're going to type ROUND, open parentheses. Go to the end, comma 2, close parentheses. Now, we still, after we hit enter, we realize, oh yeah, we have another one. So we need to come up here and type ROUND, open parentheses, and go to the end, comma 2. And this one right here is adding, subtracting already rounded numbers, and we love that. That's a lot of interest. That's a lot of gain for us. Now, why do we have to do that? Because it didn't look like it changed here at all. However, if you change these inputs, right, you come up here, because this is all an estimate. The percentage rates change from year to year, and your amount that you put in each year changes from year to year. So this is a common way to estimate, so you can plan for your future. But let's just imagine that you get 8.75, right? So that's a decimal there that may or may not have an effect here, but by rounding the dollar amounts, which need to always be rounded to the penny, we have our bases covered. Hey, now let's go on to present value. I'm going to click on the Sheet tab, PV1. Then I'm going to go over to our PDF, and this is page 8, present value. It says here, the lump sum that you could deposit today so that equal periodic withdrawals could be made. This example, as we saw earlier in these slides, this is the one where you have some money when you retire and you want to figure out how much you can withdraw at the end of each month to live on. Right? Let's look at our formula. Here's our variables, just like for future value. Come down here, this formula here, what lump sum deposited today do we need so that we can take out future PMTs? This is when we're solving for the present value. This one here is when we're going to be solving for the PMT. How much can we withdraw each period after we retire? That's one we just mentioned. Now, both of these are the math formulas, but of course in Excel, for when we're solving for present value, we're going to use the PV function, and when we're solving for the PMT, the payment, the regular periodic payment we can withdraw or get, we're going to use the PMT. And we did this function with future value, and it's the same exact function. You just either put in future value or present value, or both in some cases. Alrighty, let's go down and look at an example here by hand. If you can afford to pay $250 at the end of each month for the next 5 years at 6% compounded monthly, how much do you have today to spend on an automobile purchase? Again, here we know the future payments, right? So our goal is to solve for present value, which is today, the price that we have, the amount of money we have for an automobile. So I'm going to list my variables. The $250 at the end of each month, of course, that's the annuity part, and the fact that we're taking these future amounts and figuring out the present value, that's the present value part. PMT is going to be our $250. Same amount each period, and notice it's at the end, so that's our ordinary annuity. X, oh yeah, that's years, so 5 years. We want to put X equals 5. It says at 6% compounded monthly, so little I is our annual rate. Compounded monthly, 12 periods per year. And then how much do we have to spend? That's the present value. So then we come down here, we solve for I divided by N, and N times X. Now, these are not some repeating decimals, so I actually calculated them here because this is going to get pretty unwieldy here when we do it by hand. So later I'll just substitute these in. If this was a repeating decimal, I would actually, when I'm doing my calculation, math calculation, I would keep it like this, 0.06 divided by 12, and whatever unrounded number I would get, I'd keep that in the calculator or in the Excel and use that in subsequent calculations. Hey, there's our formula. Present value equals the PMT, and then brackets, big brackets, because we have to do all that stuff before we can multiply. And then there's a line here, numerator, denominator. That's also a parentheses or bracket or line saying do everything up here before you do the division. Then we got a bunch of parentheses here. So we're going to plug in all of our variables. Here we go. We've plugged them all in. There's our annual rate, our monthly, or our number of compounding periods per year. There's our number of compounding per years and years. Now I want to show you a little something. That minus is right here. Let's scroll up and look at our formula. See how it's on the outside there and it's on the outside there? That's perfectly all right, because if you multiply inside a negative times a positive, you're going to get a, without the sign up here like we're going to do, you get a negative. If you multiply two positives here and then after you multiply and put the negative, you're still going to get a negative. So either way, it'll work fine. So we put it there. Here, minus 12 times 5. Now, look at this. We have a lot of parentheses here, here, and here, and here. So we're going to go to the innermost ones. Let's go here and solve it. 0.06 divided by 12. Oh, we remember that that's that 0.05. So if we'd have 0.05 plus 1, we would rewrite it down here, 1 plus 0.05. Then we can also do this one. This is a separate parenthesis, so we could do it. Minus 12 times 5 is negative 60, so we put that there. So we've just rewritten it. There's the caret, exponent. We keep that 0.05 down there because we've already done that calculation up above, so we substitute that in. Now, we have this. We want to solve for this next. So we just add them. Boom. We actually probably could have just done that in one step, but sometimes it's polite to yourself when you have a complicated problem like this to do it one step at a time. There it is. We rewrite it there. And now we have this line right there, and we have 1 minus, and then a number and an exponent. So minus or exponents, which ones come first? Of course, the exponent. So we would take 1.05 raised to the negative 60, and we get this number here. 0.25 862, etc., etc. That number right there. So we rewrite that down here. We keep the 0.05 here, and we keep the minus right there. Now, we have 1 minus this, so we do that because we still have some things to solve in the top of this fraction here. Oh, now we have 0.741372196, so we have solved that, and we got this. So next, we have multiplication division. We could do this left to right, but we're going to still solve this right here. Remember, multiplication and division are on the same line when it comes to the order of operations. Left to right, multiplication and division. But you can certainly, because this is a fraction bar, and so it represents, this is a number that represents this division. So we're going to do that. We get 51.72556.075. Now we can finally multiply the two, and we get this number here with a bunch of decimals. But this is to the penny, so we have to right there. There's a 0 there, so we keep this as 9. And that is the present value amount. That's the amount we can take out and look for an automobile, probably a used automobile. By the way, if you buy used automobiles your whole life, like 1 year old, if you know, most of you probably already know, if you buy an automobile that's 1 year old, there's like a huge discount, $5,000, $10,000 sometimes. And if you were to buy used vehicles over your whole life, just that amount saved would be a huge chunk when you retire. That's one of the tricks about becoming a millionaire or a multi-millionaire when you retire. Buy used cars. All right, here's our conclusion. If you can afford to make a payment at the end of each month for the next 5 years, and you can find a loan for 6% compounded monthly. By the way, I left out $250. If you can afford to make a $250 payment at the end of each month for the next 5 years, and you can find a loan for 6% compounded monthly. Wow, this is late at night. That's monthly. It's just supposed to be one monthly. Then you can afford a $12,931.39 price tag. All right, let's go over to Excel. We're going to go ahead and do the same problem here. If you can afford to pay $250 at the end of each month for the next 5 years at 6% compounded monthly, how much do you have today to spend on an automobile purchase? All right, let's go ahead and list our variables and details. Okay, so it looks like the first thing here, $250 at the end of each period. That's the annuity part. That's the payment. So I'm going to come down here and type $250. Then it says for the next 5 years, so I'm going to go down to years and put 5. Then it says at 6% compounded monthly, so the 6% is the annual rate, and compounded monthly, that's 12 periods per year. So I'm going to come down to annual rate, 6%. Notice it's pre-formatted because that percentage comes up. Number of compounding periods, 1, 2. Let's calculate our period rate equals 6% divided by 12. Enter. Let's go ahead and calculate our total number of periods. N 12 times 5, 60 months. Now, this is at the end annuity, so I'm going to put a 0 here for our Excel function. Now we'll come down here, and we saw how to do the PMT in the present value in last chapter, so we're going to go ahead and just type this in, equals PV, open parentheses. Aha, we know by now that rate is a period rate. Remember, if you forget, you go ahead and click this, and then it will give you some hints about each one of the arguments. All right, so rate, the period rate, comma, NPER, that's going to be the 60. Comma, and it says payment. We get to use a payment here in this present value calculation, unlike the last chapter. Now it's going to be $250, but we know we're going to put a minus because this $250 is going to come out of our wallet each month. Comma, there's no future value. If you actually did have a future value, like you still owed a big chunk at the end and you were going to pay it off in one lump sum, you'd put the amount there, but we don't have one. And the type. This is an ordinary annuity, so we're going to click on that 0. Close parentheses. $12,931.39. So here's our answer. If you can afford to pay $250 at the end of each month for the next 5 years at 6% compounded monthly, you could afford a car with a price tag of $12,931.39. At least this one has more or less the correct answer, unlike that one in the drawings with monthly. Hey, let's go on and do our next one. Notice here we solved for the present value, right? We knew how much to put in each month. And so we knew that, and we need to figure out what we would have today to purchase a car. Our next question, PV2, this one is slightly different. If you have $500,000 when you retire and you plan to live for 40 years, and you get an 8% compounded monthly, how much do you have to withdraw each month from your account? Again, here we know how much we have in our hand on the day we retire. And the trick to this problem is realizing even if you were to make this calculation as a young person and you think you're going to have $500,000 when you retire, if you're planning after retirement, then you're in essence standing at that moment in time, the day you retire, with $500,000. So that's why it's considered the present value. Then you're going to look into the future. How much can I withdraw each month? So here we will use our PMT function, but have a present value amount of $500,000. So let's come down here. Present value. We'll type $500,000. Regular payments, that's what we're trying to find. So I'm going to put question. Annual rate, looks like it's 8%. Number of compounding periods looks like monthly, so that must be 12. By the way, you've seen that sometimes we type it in, sometimes we don't, but in general, if you're always going to do a monthly calculation or always a quarterly calculation, and that variable is not going to change, then you could actually type the number 12 into a formula. But here, perhaps it would change, so we've typed it in as a variable that could change. Looks like we still need years, right? We're planning to live for 40 more years. So I'm going to type 40. We retired when we're 70, and we're planning to live till we're 110. All right, so now we come down and we need to figure out this is an annuity due or ordinary annuity. Let's see, withdraw at the end of each month. If you were going to withdraw a big chunk on the very first day of a retirement, then you would have an annuity due. And you'd put 1. But no, we're going to say, oh, no, we'll do it at the end of the month. So 0. And really, that is the most common. In fact, we'll change it and see how it changes our payment in just a moment. So here we're going to use our PMT. Equals PMT open parentheses, and the rate we know by now is the period rate, comma, NPER, 480 months we're planning to live. The present value. Now I'm going to put a minus in front of this because when we're putting this in the bank on the day we get it, they finally give it to us, and we're like, yeah, 500,000, but then you say, oh no, I got to put it back in the bank, and so it's coming out of your pocket. So we're going to put that. Comma, there is no future value, but this is a great one. If you want to leave like $100,000 to your kid, you would put a future value amount, and it would know that you want $100,000 when you pass away to give to your kids, and then it would properly calculate a payment that you could take out and still have $100,000 when you're left. We're going to skip over that one, comma, and the type is 0. Close parentheses. And I don't think we're going to use this in any subsequent calculations. However, if we do, we'll come back and put that round. There it is. And again, the format is sufficient if you're not going to use it in any subsequent calculations. In fact, let's go ahead and increase the decimals. Oh yeah, see, it's got a bunch of junk hanging out there. So, but we're not using the calculation, so that's fine. The format shows us the 56 cents. There it is, $3,476.56. Now, just for kicks, let's see how this might change if we have a future value amount. I'm going to type future value, and I'm going to put in parentheses amount to give to kids. And I'm going to type 100,000. Better add a little formatting here too. Boop. Maybe I like that one. Now I'm going to come down here and hit F2. See that little place right here? I'm going to try and click right there. If I can't quite get to it, I can click up here. If I still can't get to it, then I can click up there and use my arrow keys to move till I get to that. When I see the bold future value, I'm going to keep it positive because that's going to come out of the account and to someone else. I'm going to click here. Now this is cool. Financial planning. Oh, you're kidding. Not much difference. I'm going to do that. I'm going to give that 100K to that kid. Let's click undo and see. 76. That's the power of compound interest. You got to be kidding me. 76. So we're going to forego, 30 some odd dollars a month? That's pretty amazing. Let's do another calculation because this is all variables. Let's change this to 7%. Wow, still get to give them in. We get $3,069. Let's also change this, because let's say on the day you retire, you're like, no way, I'm taking out this little payment right now. I'm going to spend it immediately. So I'm going to put a 1 here, which changes it. Now the annuity is an annuity due. And we've properly linked it so this thing will update. Wow, not much difference. The power of Excel right there. Change the variables, see how your resultant formula changes. So now that formula is a little bit different here. I'm going to show you how to scoop this out. And we'll put a little label up here and a little label down here. I'm clicked on this cell, and just so I can remind myself later and see it right off to the side, I'm going to click up in the formula bar and highlight that whole thing in Control C. And I'm going to come down right below, and I'm going to say Control V. Oh, wow, that's a cool way. Instead of using this little fill handle here to copy down, because all of these would have moved relatively, I scooped it out and then placed it down there. And watch, I'm in cell B19, now in B20. Oh, same formula. That is a good trick. If you want to copy the thing and not worry about whether they're relative or absolute, that's a good trick. Now, I'm going to do it one more time. I'm going to click in this cell and hit space, and then Control V, because it was still loaded in there. Now, I have my calculation here and my formula here. Now I'm going to come back to this one, and I'm going to edit it, F2. And I'm going to come up here or right here. I'm going to come up here because it's safer. I'm going to click on the future value, and watch this. In the middle of a formula, if you double-click in the middle of a cell reference, it knows to highlight just the cell reference. It'll leave the commas and everything, and then you can delete. Enter. Now we can compare the two, the $1 million one or the non-$1 million one. Now I'm going to change this back to 0. And then I'm going to come over here and say monthly PMT with some left over for kids. All right, that's pretty cool. We'll leave it there. So I can forego the difference between those two and leave some for the kids. That's pretty exciting. I'm going to go to our next sheet tab, PV3. And here we are going to compare two offers. So you're given an offer. Hey, let's read this. If you were offered $200,000 in your hands today, or $80,000 in your hands today in payments of $10,000 at the end of each quarter for the next 4 years, assume that the money could be invested at 8% compounded quarterly, which would you choose? Now, this doesn't have any details, but if you're selling something and someone says, one person says $200,000, I'll give it to you right now, and another person says, no, I'll give you $80,000 today and $10,000 payments quarterly for 4 years. You have to decide which one. Here's the deal. If you have, this one's all right now, this one's some right now, and a bunch in the future, you can't compare these because there's something called the time value of money, right? This, if something in the future, something right now, we have something called interest we need to take into consideration. So if we were to multiply all this, we get 10,000 times 4 times 4, we'd get way more than 200,000. But that's not a fair representation because we need to actually do a present value calculation on this 10,000 and then compare it. And that's what we're going to do down here. And then we're going to take this number and put it down here. And then when we get numbers all in one moment in time, when we get all the present value for here today, what is it all worth today? And this one obviously is worth 200,000 today. Then when we have them at the same moment in time today and today, then we can compare them and see which one we take. All right, now this is the hard one. Present value of this. If you have $200,000 in your hand, what is the present value of it? Yeah, that's right, 200,000. And I'm going to tab over here or enter and click in cell D18. Here's another question. If you have $80,000 in your hand today, what's it worth? What's the present value? 80,000. Now, the present value of the $10,000 payments, once we calculate this figure out what it's worth today, assuming this interest rate. Then we have all of these $10,000 future payments in a lump sum today, what it's worth today. Then we can add them and see, is this bigger or less than this? And so this is how you would compare two offers. All right, so let's go ahead and do it. This is a present value calculation of these future payments. And this isn't an annuity structure because same payment, equal time periods. So equals PV. The rate, I've already calculated the period rate, comma, NPER, 16, comma, and the payment, we're going to say minus 10,000, and then comma, because we don't have any future value amount, and comma, because here's the type. This is an ordinary annuity. Close parentheses and enter. $135,777.09. So now we're going to alt equals and add them up. Ding, 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 ding. Which one now would you prefer? 200K or 215? We take the 215. What if the interest rate was only 4%? We'd still take this one. What if because then we're taking out, in essence, we're taking out less interest when it goes down. But what if we said this is too risky, so we say 15%? Now that number right there is less than that, so we would take this. Let's undo. So, stated answers. If I had to choose between the two offers, I would take the one with a higher present value, 215,777 and 9 pennies. Hey, let's do our last example for this vlog. This is exciting. This is perhaps the most exciting one so far in this chapter. We're going to plan our entire retirement from right now when we're young to when we retire to when we die, all in one fell swoop. Here it is. If you make monthly payments at the end of each month of $250 for the next 35 years and you can earn 10% compounded monthly, how much will you have when you retire? Make your calculation in B12. Well, we got it in there. So let's go ahead and do it. I've listed the variables. We have monthly payment, annuity, and we want to look into the future. So we're going to use future value equals FV. And it says, hey, what's the period rate? We're going to click on the period rate, comma. What's the NPER? We're going to click on the NPER. What's the payment? We're going to type a minus and click on the payment. What's the present value? We don't have anything in the account right now. What's the type? We're going to click on this 0 right here. By the way, if this is in the way, that screen tip, which it is sometimes, that cursor right there, that's the one, when you see that one, you click and drag. Get over there. Okay, and then close parentheses and enter. Wow. 949, 159, and 51 pennies. Now the trick to this is, and I'm going to delete that, what's in B11. The trick to this analysis, remember we were standing here saying if I put this in, what do I have when I retire? Well, that's what I have when I retire. But the next calculation is at the moment we are retired, let's plan into the future. So we need to switch gears. This was from us, younger, looking into the future, but now this is from when we're older looking into the future. So this was the future value, but on the moment you retire, if they give you this, if this is in your account, it's the present value. That's the conceptual trick to this problem here. So I'm going to say equals and get that amount. And by the way, I'm going to come right up here and round it because it looks like we are going to use this in a subsequent calculation. So right here, click in that cell and up to the formula bar, round, open parentheses. Click at the end, comma 2, close parentheses. All right, now that doesn't need to be rounded because this look in there, it's already rounded. Now let's think about this problem. We're standing here, this is the present value, and what we want to do is figure out how much we can withdraw each month. So this is going to be our PMT, equals PMT, open parentheses. We've already calculated with a formula the monthly rate, the period rate, comma, NPER, 480, and you could just change these variables however you want. That's the beauty of Excel. Comma, the present value, we're going to say minus because the day you get it, you're like, woohoo, 949. And then you're like, oh, got to put it back in the bank. Back in the bank is out of your wallet, so it's a minus. Click on that. comma, future value, we're deciding we want to spend it all, we're not going to leave any for our kids, comma, and then type. It is a ordinary annuity. We're going to take it out at the end of each month. And just like we saw in the last example, you could change any of these to suit your particular situation. Close parentheses. Whoa! That's great. Look at that. And I'm going to round this here. I'm going to come back here and round it because we're going to use it over here. We're going to see the power of compound interest. Since the last couple chapters we've been talking about compound interest, which is the most common type of interest there is. So it's important to know about this. Round. Come to the end, comma 2, close parentheses. Here's the question. I want to ask, how much did we put in? How much did you put in? Not including this, because the day you got this, you put it back in there. But I'm just saying the actual cash that you put in each period. How much in total did you put in? That's right. Simply the $250 that you painfully took from your paycheck each month and put into the, or maybe it was an employer match, so you put $125 and the employer matched $125. But all you put in was $250 times the total number of months. So we're going to click over here, and I'm going to type equals round because I am going to use this in a subsequent calculation. $250 times 420. That's it. That's how much you put in. Comma 2, close parentheses. Enter. You got to be kidding me. All I put in was $105,000. That's right. 250 times 420 is $105,000. But what about this one? What was the total amount that you took out? Look down here. How much did you take out each month? How many months? Let's do the calculation. Equals round, open parentheses. This amount, which was properly already rounded, times 480, comma 2, close parentheses. You gotta be kidding me. You see that? And this is pretty simple math. That much in, that many times, boom. That much out, that many times, boom. 2,831,217.61. And what's the difference? Equals that minus that. That's all interest. That is amazing. Save this one. Make it. Hopefully this makes you think. Even if you start now and you put a little bit in each month. Remember, the variable that matters most is what? Time, years, total months. All right. When we come back, we will do our last section, sinking funds. If we scroll over, sinking funds, if we click on Sync 1, it's just a fancy way to say savings plan. See you in just a moment.